All good.
Great. All right. Well, thank you very much. Welcome everyone to the last talk on the expert stage here on Saturday of the decarbonisation hack from home that we're running here at DataSwift. We've had a busy schedule of workshops, webinars, people putting their ideas together and coalescing into teams to work on their app and project ideas. It's been great to see. At the same time, we've also had various interesting talks on trends in the energy sector here on our expert stage, including stuff on cybersecurity, energy prosumership, the future of heat, smart meters, and more besides. Our final talk is Daniel Schwab, CEO of Brightmerge, yeah, we're looking forward to it. So Daniel, without any further ado, I'd like to hand over to you into the presentation that you've got.
Well, thank you, James. Good evening, everybody. It's a pleasure to be with you here. My talk is really to just share some thoughts and ideas and experiences from the world of developing local renewable energy communities. The company that I founded several years ago, based on the experience that I've had as an entrepreneur in the renewable energy industry. The purpose of it is to essentially take the entire issue of data and put it onto a platform where we can essentially collect, analyze, and then report on the data that's required to make decisions as to how investments will be made in renewable energy microgrids. So just for those of you who are not familiar with Brightmerge, sorry. The company was founded in 2018. We're 6 people now. We've been supported by the US and Israel innovation authorities and energy ministries of energy. And we've had involvement in European Union funding programs, as well as essentially working with the industry, energy leaders who are at the forefront of bringing renewable energy, local energy systems to the market. So our team is a highly experienced team of experts in data management, software development, and renewable energy project development. We've got an international board of advisors, so we have access to quite a broad range of input from disciplines such as enterprise software, as well as financial management and investment, media, one of the leading architects in microgrids, and the utility space. So as an integrated platform, we have to understand the full ecosystem of developing renewable energy communities. Just to define it for 1 second, perhaps I'm speaking to the choir, preaching to the choir here, but essentially, when we talk about renewable energy communities, what we're talking about is a collection of consumers and producers of energy, and with mainly solar panels, but it could be wind and other sources of producing energy locally, and enabling the consumer to manage that flow of energy in and out of their homes or industrial and commercial enterprises. So we keep it agnostic to technology. From our perspective, we try and avoid picking winners. We think that the technologies available today are commercially viable, and so essentially there needs to be a flexibility to select the types of technologies that are best suited for that particular location. So we can integrate multiple systems, and also taking into consideration the fact that the grid is going to be available to us and viable for many decades to come. And so when we talk about microgrids or local energy communities, we are talking about systems that are connected to the utility grid. And based on our research, we think that this is the new way of delivering and managing and producing energy, because it is just so cost effective, reliable, and sustainable. So this is not just a ideological adoption of technology because of any kind of sort of feel-good interest, but there's a lot of business drivers and real hard evidence to show that adopting local renewable energy systems is the way to go. So in terms of defining them, as we say, it really is about providing the full integrated system. Having that independence from the main grid is a key factor of local energy systems. And so we need to look at it as an entity, and how that system operates is critical to the value that it can produce. Many people are not aware, but there are thousands and according to some databases, tens of thousands of systems already installed around the world. These are just a few examples at the moment that are already have a successful implementation in the US, but there are local energy systems around the world, in Asia, in Africa, and in Europe. And they're getting more and more popular. So this is a trend that is really taking over the energy system. And we see it with our clients, we see it with the people that we interact with all the time. The interest in local energy communities is just skyrocketing. The challenge is implementation. So you need to have multiple factors in place in order to have a successful energy system developed, local energy system developed. So you need to have a mandate. So is there a local mandate for renewable energy? Does that community want to take advantage of the economic value and instead of it's essentially exporting that economic value out of the community, there's a drive and an interest in keeping that economic value local. And obviously the reliability of the system. So the more that there's a need for higher levels of reliability, if it's a data center or a commercial driver, or there's a hospital in your community, elderly people, education, these are essential services, and reliability of energy is critical. And so what we find is these local energy systems are actually more reliable than if you just have a macro grid. And so there's also new types of technology that are coming into local energy systems, such as electric vehicle charging, where you have bidirectional flows of energy, so the grid can charge the electric vehicle. And so at times in the evenings, for example, but when the need arises and there is an economic need justification for charging from the vehicle to the grid, that is also a possibility. So vehicle to grid technology is also important. And lastly, safety and security. So we find that local energy communities are more safe, but both in terms of threats from cybersecurity, extreme weather, and any kind of terrorist behavior. So unfortunately, we have to deal with that as well. We think that based on our research, the need for these systems is global. So even if you've got a fairly robust and reliable national grid or regional grid, local energy communities can be of benefit. And ideally, you want to have a significant size community that is adopting these systems. And so just to wrap up, and at the end, I'll be happy to take questions and perhaps address the issue of data, because that's key. But as you can see, it's first important to understand the fundamental drivers, why this is so advantageous. Once you understand the value of local energy communities, I think then we can then address the data value. So how important and how valuable is personal data? And so how we use that data to extract the most value for the owners of that data, being the citizens or whoever else is a stakeholder. But there is a tremendous amount of value in developing systems and therefore the data that is required to design them. We look at the data flow in terms of the initial installation of systems. So we look at the GIS data, the community production, if there's any existing production facilities, solar panels or wind turbines, fuel cells or geothermal, hydro. We'll then also look at the consumption data. So if there are smart meters, of course, that's of interest to us, and we would look to understand how energy is being consumed by the various consumers in the system. And then we also take the external data, so the weather data, utility tariffs, understanding tax benefits, local incentives, anything that could potentially impact the performance of the system from a financial and operational perspective. And then we produce essentially is a dashboard of decisions where you can understand what is your bill of materials, how much is it going to cost for you to install your system, how much is it going to cost for you to operate it, what is going to be your return on investment, and your cash flows, and any other key performance indicators. So essentially bringing that data into a system that can be analyzed very quickly and produce these key performance indicators will allow a far more rapid way of achieving a bankable project. And that at the end of the day is the key issues. How do you get to a bankable project? And that is really important. It's coordinating all of that data into a model that is bankable. And you want to do that where risks are reduced, where you're looking for ways to optimize. You don't want to overinvest in your system. Obviously, that would be a asset that you've invested in that wouldn't be utilized, and that could have a dampening on your return on investment. So that's essentially how we look at the world. The data, as I say, the personal data, this is a very interesting topic for me. As someone who's knowledgeable in renewable energy, and looking at how personal data could improve the deployment of renewable energy systems, I think that there's a lot of interesting ideas that perhaps we could share with you in a discussion. So I look forward to your questions, and I'd be happy to address any questions you might have. Thank you.
Well, thank you very much for that. That was really interesting. Learning more about particular systems and the platform that you have. One thing that wasn't quite clear to me, so who typically is installing these systems? I guess who's your client base?
Yeah, so
that you see actually engaging them?
Yeah, so it really is. It needs to be a multi-stakeholder team that is installing them. Ideally, you want the buy-in from the local community, maybe represented by the municipality or the town representative. There needs to be some kind of civic organization with whom you can communicate and have that discussion. Getting that buy-in is critical. But then once that buy-in is achieved, usually it makes sense to have a professional energy company that will essentially take leadership in developing the project and then installing it and operating it. It is very complex. There's a lot of legal and financial and technical expertise and knowledge that is required. So we would highly recommend, what we see is typically there's a partnership between civil society and a professional energy company that has that expertise to do this.
Is it, yeah, I mean, one of these sort of interesting trends we've come across is at the community level, people wanting to take control of their own energy resources, and this is sometimes, most obviously being municipalities, but actually often being even smaller units. Have you been finding even smaller units either, communal associations of some sort, or perhaps just, I guess, particular institutions, like, I don't know, say a school or hospital doing this much, or is it always slightly higher?
Well, I think that, you know, there are schools and hospitals that might do some kind of level of system. You know, that definitely is that does happen. We think that, you know, when you look at when you do the models and you see what the advantages of collaboration in a broader community, because, for example, you might have downtime of a school, right? So school might operate from 8 a.m. in the morning to 4 p.m. in the afternoon. Then they shut down and there's no consumption. So if you're installing a solar system there, there might be some level of match between production and consumption. But then in the weekends or the evenings, if there's a wind turbine, so you've got to be able to have different consumption patterns in order to take advantage of the asset. The more you utilize the asset, obviously the economic model improves. So, you know, it might be done by an institution, but you don't really take advantage of the full value of the assets if you do it that way. My recommendation, based on the data, is try as best as possible to build a more broader community collaboration. And so that way you really are going to look at significant improved economic outcomes. And I think that it's going to be a more professionally managed system. So it's going to be well maintained because it's a larger system. You can then afford to bring in more professional experts to manage it. And I think that that's going to be your winning, the winning kind of model.
Interesting. And in terms of, you know, you had the point, oh, actually, no, I was about to ask a question, but I see you had someone come in from the floor. Anonymous attendee, I was wondering, yes, the question is, someone was wondering how you might try to integrate, so I was wondering how you might try and integrate personal data into the local renewable energy communities, but those that have low levels of capital. So the example that this person came up with is communities in, you know, remote and desert areas like the Australian outback.
Yeah.
Any thoughts on that?
So that's a very good question. You know, definitely there are organizations that focus on low-income communities. You know, the World Bank, the European Union has various financial facilities. There are impact investors that might get involved. I know that, for example, the Rockefeller Foundation has done quite a bit of work in India. They're trying to get some initiatives off the ground. There's a few companies that are focusing on Africa. I'm less aware of those in Australia. But I think you know, that is a very important aspect of local energy communities where, you know, low income communities need support because it is complicated. It requires a significant upfront capital investment. So, you know, we would love to, you know, there are some banks that might get involved there for their sort of impact investing programs. But it's a challenge, you know, because you really do need some level of certainty about the available cash for paying for the service if you are doing it on an economic basis. So low income communities need some kind of subsidies. They need some kind of tax breaks and other kinds of government societal support. There are a bunch out there. I think I can share with you some of those links at the end of the presentation, and perhaps the person asking the question can you know, contact me offline and I can share some more specific details.
Absolutely. Well, thank you for that. I want to ask you a bit more about the electric vehicles component, which you mentioned at one point in your talk. How do they play in?
Yeah, that's a great one. What we're seeing is that the electric vehicles is going to play a significant role in the management of the grid because it's got available storage systems that are mobile, and the capacity, if you add them all up, is going to be quite significant. And so, if you're coordinating it and the data is managed properly, you can have the vehicles, when there's a spare capacity, incentivized economically, obviously, to sell back into the grid. That would support the grid. That would require a lot less installation of static storage. And so the fact that the storage system in a vehicle is being used both for transport, which is replacing oil, which is a lot more expensive. So the economics is better in terms of using storage for replacing transportation fuel versus the utility, which is a lot cheaper. So it's much more difficult from an economic perspective. So yeah, so definitely electric vehicles are going to be both a consumer from the grid, but also it's going to sell back to the grid. And that could be a very valuable resource. So I would recommend anyone developing a local energy community from day one, consider electric vehicles as part of the package.
Do you see, so one of the things that we generally talk about on multiple levels here at DataSwift is decentralization, which obviously can mean a whole range of different things depending on where you're applying that term and what systems. But do you think that this kind of decentralized microgrid setup could be the new standard? We had a particular question come in just now on that. Do you see a whole world of multiple decentralized microgrids all the time?
Well, there we go. Exactly. I mean, if you look at, there's an organization called Gridwire Alliance. I can share that on the chat. Gridwire Alliance from the US. There's a European organization as well. But there's definitely the think tanks and the people that are thinking 10 years ahead. It's a no-brainer. It will not be the only way of managing electricity. It will be in tandem with the grid. So you'll still have transmission lines, probably you'll still have distribution in a broader regional level. But microgrids are certainly going to allow us to increase substantially the capacity of the grid at a fraction of the cost. It's going to open up a lot of utilization of relatively unused grid capacity. So what they call non-wires alternatives. So when you need to expand the grid, you either have to pull up more poles and wires. Microgrids essentially can be an alternative to additional wires and poles.
Just less infrastructure required, in effect, or less national level infrastructure.
Yeah, I mean, just think about it, where you're producing the energy and consuming it immediately, directly at the point of consumption. So you cut out, the cost of energy today, when you switch on your light at home, the cost of energy is made up of generation and then the transmission and distribution. And the transmission and distribution cost is maybe 40%, sometimes even more. So it's a big saving if you can cut that out.
Interesting. Okay. Yeah, I sort of imagine a whole range of interesting opportunities coming out of that. Quite major implications. We've had another question come through, which is on the consumer side, which is good, given our interest in consumer data. So I don't know if you can see it. The question is, will local renewable energy networks end up reducing or increasing complexity for the consumer? Often those who are apathetic about improving energy efficiency will stick with the simplest course of action, route of action, I should say.
That's a great, sorry. Yeah, that's a great question. I think it's, it really is up to the engineers who design the systems and the service providers. It's our job as service providers to come up with the simplest way of delivering the service, right? So, there are models that, yeah, it might be a little bit more complex to kind of design the system initially, but there are certainly ways of keeping it very simple. The consumer doesn't even have to know about it. The consumer doesn't even have to worry about that. I think that's why I think the local communities, the municipalities need to get involved, the civil organizations who work with the professionals, because like this person has said, the consumer doesn't want the complexity. So it's no use going to Mrs. Jones and saying, look, you should put a panel on your roof, and by the way, here's an app which you now need to understand how it works with, what the price of electricity is, and you have to make all these decisions about buying and selling, and you want to become an expert in energy. I don't think that is a recipe for success. Mrs. Jones does not want to have to think about energy. What you want to do is make it really simple. It's like your cell phone package. You click on, the package that makes sense for you. You tell them, look, you're spending £100, whatever, let's put £20 a month, and you can buy, according to your consumption patterns, here's a £15 a month package. You're going to save £5 a month if you switch to this new model, and all the complexity can be handled in the background.
Yeah, I think that's a really interesting point, because we have this whole idea of the energy prosumer. People both using the energy, but also creating it either like individually in their house, or I guess as small collectives. But one thing that I think some of the more excitable commentary on this doesn't really comment on is just how boring this is to a lot of people. Fighting over and trying to save 2% here and there. So definitely systems that can automate this and make it as easy
needs
as
to be
possible.
Absolutely. If you're an engineer or you're a company that is involved in coming up with solutions, try and think about how to make it as simple and fun for the consumer. If you want to encourage them to change their consumption patterns, for example, let's say you've got a overcapacity at a certain time of the day, and so you want people to start spending, using the spare capacity, and you want to motivate them. So you've got to come up with some kind of gamification, make it really easy. Maybe they will look at it once a month and then they click on it and that's it. I can't imagine, again, maybe I'm wrong, but I can't imagine, someone wanting to look at their electricity consumption patterns every day.
I'm sure there are some people out there. There's always all sorts in the world.
I'm probably one of them.
Yes.
I know I would.
Yes. Perhaps not enough for a scalable a tech company scaling to uniform status. But yes.
But I'd be interested if you had any in the workshop, in the earlier calls. In the earlier presentations. Perhaps there are behavioral, let's call it behavioral scientists who could shed light on that. That'd be a very interesting topic.
Yeah. So we actually our first talk was on kind of behavioral, smart meters in general, and kind of behavioral tweaks that engineers need to consider, because some of the cognitive biases people have. So the sort of the basic example that that speaker used was, if people know they're saving energy because they have a energy saving light bulb, then lo and behold, they actually switch on all the lights in their house all the time, thus meaning that they use more energy. We actually have another driving behavioral change talk coming up tomorrow, which will definitely send you the link to when it's done. All pretty interesting. We actually have a peer-to-peer energy trading project underway at the hackathon. So I guess depending upon how they're currently conceptualizing it, this might be useful considerations for them too. Wonderful. All right. Well,
we're definitely involved. We're involved in that peer-to-peer. Sorry, just to end off, we are involved in that peer-to-peer sort of development, and it'll be interesting to see how these these pilots, what the results are. And if you guys have any access to results, I'd love to, you know, see them and see how they come out. Do they really add? You know, is there a real significant advantage of peer-to-peer?
Absolutely, absolutely. Well, there's a lot to learn. Some very exciting ideas running around both in this event and in general on peer-to-peer and these other trends. So I look forward to diving into them more tomorrow, and then, you know, as we have our follow-up agenda in the weeks and months ahead. But look, thank you so much for your time. Really appreciated it. I know you have a holiday coming up as well, so I appreciate your time this evening. It's been a really interesting talk here about what you guys are up to and the considerations around microgrids and SaaS products around them. Thanks so much. We've recorded this talk and we'll be sharing it on our media channels. Hope that's fine with you, but, you know, speak now or forever hold your peace on that particular point. And yeah,
that's right. You have my permission.
Great stuff. Great stuff. And we've got you on video saying that now, so you're trapped. All right. Wonderful. Yeah. Well, have a great evening, and thanks again for your time.
Thank you. Thank you, everybody. Thank you.
Great stuff.